So let's look at a couple more example problems for finding the area of parallelograms. And remember that parallelograms have opposite sides that are parallel and of equal length. So this would be length 6. Let me change colors. This would be length 5, but the opposite sides are parallel to each other. And to find the area, remember in the introduction video that essentially what we did is right at this corner drew a line that is perpendicular down, and it would have this same length of 4. And we took this triangle here, and you can imagine cutting it out and moving it over here so that that triangle now fits perfectly into this empty space here. And we would now have a rectangle where this was the height of the rectangle and this was the width of the rectangle. And we know how to find the area of rectangles. It's just the length times the width, or the width times the height, depending what you want to call those. So let me show you just a quick picture of what that might look like. And you can see in this animation that actually they didn't cut out the triangle part, but it doesn't really matter. You can cut out where the dashed line is as long as it's a perpendicular line. So they cut this part out and then just moved it over here, and it perfectly fills in so that we have a rectangle. So the brown part was just moved so that it's on the other side. And notice now with this rectangle, we know how to find the area of the rectangle. It's just whatever the length is multiplied by the width, or if we want, we can call that the base and multiply it by the height. So the area formula in general for a parallelogram is, again, the base multiplied by the height. And it's the same as a rectangle since we can always transform a parallelogram into a rectangle. And so to use this formula, we just need to label what the base and the height are. And the base and the height, remember, they have to be perpendicular to each other. So this side length of 5, this will not be used for finding the area because it's not perpendicular to either the base or this vertical height here. So we can label this as the base, and this length of 4, this is the height of our parallelogram. So when finding the area, we just plug those in. Our base is 6, and our height is 4. And so the total area, how much flat space this parallelogram takes up, is 24, and we'll have square units since it wasn't specified what the unit is. So that's the general process. If you want to understand where this formula comes from, it's from taking the parallelogram and transforming it into a rectangle. But ultimately, you just need to remember the formula that whatever the base is, you multiply that by the height. So let's do one more problem. And again, with this problem, we could transform it to a rectangle. So we can take this triangle and just move it here so that it perfectly fills in, and we have a rectangle where we know the base is 4 and its height is 7. Or we can just use the formula. So the area of our parallelogram, that's the base multiplied by the height, so we just need to label those. And we're looking for the two lengths that are perpendicular, so that have a right angle between them. So usually the dashed line, the one that's not actually the side length, we typically call that the height, or we can use the letter H, and we can call the side that's perpendicular to that the base. And often we'll just use the letter B for that. So you might see area is B times H for the formula. But plugging in our numbers here, our base is 4, our height is 7, and so we get 28. And again, we're dealing with square units since it wasn't specified what the units are.